So I'm going to start actually with something that I've been fascinated by for a while, which is, it was pretty clear once you invented the internal combustion. So you brought up wind tunnels, right? And the history of the wind tunnel is one of the most fascinating stories of all time, right? So once you invented the internal combustion engine, people knew it was somehow we're going to figure out how to fly. It was just that, that was one of the many applications at the internal combustion engine, and people were like, that's great. And they also knew that to do that, you would need to design wings and understand airflow and understand fluid dynamics, which was a very embryonic field at that point. And the leading wind tunnel, the leading person who provided those measurements was Lilienthaler, who was the greatest aviator of the 19th century. But he wasn't that great. And the reason is that he took his measurements, built an early glider, and then promptly crashed and died. But that was the only numbers people had. So all of European aviation, which was well ahead of the US, used Lilienthaler's numbers. And if you had to ask what was the key insight of the Wright brothers, they had two insights. The first was a conceptual insight, which is opposed to many people who just thought you just needed more thrust. If you just had just a big enough engine, you could overcome every other problem. Their first understanding was that they were very clear on was that if you want to make an airplane, first you need to make a perfect glider, right? If you can make a perfect glider, then making an airplane was going to be easy. The second thing they understood, right, and they had a very frustrating, 1901, when they first went down to Kitty Hawk, is they came back during the winter, they got very sad, and they basically decided to just build their own wind tunnel, right? And they built their own wind tunnel, and they made something like 400 simulations during the winter. And then they went back to Kitty Hawk, and then it was very easy. And they weren't just like they didn't win that race by like a month. They kept the airplane basically secret for 7 years or 6 years, right? And it was only when they arrived at the Paris Air Show that people still thought it was impossible. And when they flew around the Eiffel Tower, people said, well, they believed it, okay? Other things, I'm not sure if Kevin Bryan's here, will tell me all the bad side of the Wright brothers and patents, but that's a story for another day. But the reason I bring that up, okay, is I was struck by that analogy for you guys, and both its removal now. But I want to ask you, I guess this question is, both of you brought up in your talk the importance of data and data accuracy, data labeling, having data sets that let us solve for the kinds of problems that Abe is solving for. I guess one question, either maybe you could talk from life sciences more generally, where are we just not, where do we have the Lilienthaler numbers? Well-intentioned, maybe perhaps, but just wrong. And where do we not even have the data? And whose responsibility is it to be producing the data that would let us attack with these incredibly powerful tools?
Okay, so in my space, let me begin with the Lilienthaler data. So one of the data sources we use, there's a public data set called PubChem, which is maintained by the NIH. And the last time I checked, it had 240 million data points, 98% of which fails our quality control tests. All right. So I can give you an example of how it shows up. There's a professor at UNC Chapel Hill, Alexander Tropcha, who's written some great work about this. But basically, you'll go and you'll see a protein, a molecule, and a measurement of how well they stick, how well they bind. And the measurement will be 8.241 nanomolar. Okay. And you'll see the next line in the database, same protein, same molecule, same 8.241 millimolar. Okay? And so that's the same number, but off by a factor of 1,000,000 from each other. Okay. And so you look at it and you say, I don't believe that those are two separate experiments. And in fact, if you go back and dig into it, you'll see that somebody fat-fingered. The letters N and M are next to each other on the keyboard, and so it was a typo when somebody was uploading the data. Okay. And if you don't appreciate, this may be the domain expertise, if you don't appreciate exactly the manual effort into getting things into a database, then, and you just say, the network will figure it out, right? What the network naively will learn to do is to learn the average of those two. And it's only when the poor schmuck of the medicinal chemist who tries to use your prediction, right, runs the experiment, they realize your predictions were off by 500,000 in one direction or the other. Okay. And so we put huge amount of effort into data cleaning and data quality. That's data that exists where you have to be incredibly skeptical. I think data which doesn't exist, like it gets more and more expensive the later and later you go. So clinical trial data gets extremely expensive. And so here, people talk about personalized medicine, and I think there are versions of it which work, and we're working on some of those. But I think there are versions which don't, which say, if only we had your genome for cheap, that's going to unlock personalized. But like, when you go to your doctor today, they don't prescribe differently if you're 100 pounds or 200 pounds. Right? We don't prescribe differently if you're a man or a woman for many, many drugs. But those are easy experiments to run, right? Easy data to get about you. And it's difficult to incorporate it because the clinical trials to separate turn out to be difficult and expensive to run.
See, I haven't thought about that before, but it seems that some that jump to mind, I'll start with the medical field because it's the one where I've seen the most of it. First is just data entry errors, like you were mentioning. We've looked at a number of companies in medical imaging, and they're just astounding, the errors in EMRs. There was some data set out of the UK where I think it was between 4 and 6% of all OBGYN patients were tagged as male, and they probably weren't. And then they look more broadly, because that's like, how can you after the fact know, without going back to the original doctors? It's actually very hard to purify an error rate, and sometimes those small error rates can make all the difference in a discriminatory network that you're trying to train. So there's bad data entry. How do you clean it up? Some of those companies have concluded, and in fact, one Imogen out of New York, it's like, we are going to start from scratch. We're going to ignore all public data sets and only have our human experts, per the earlier question, make sure that we're training our networks on known to be good gold sets, if you will. So data entry errors. Second could be categorization errors in medicine. I'm thinking in the field of psychiatry in particular, there's a lot of new work out of psychedelic research, of all things, showing that MDMA and psilocybin have profound effects across what are a wide variety of DSM categorizations, so much so that the researchers at Johns Hopkins and elsewhere are concluding the entire book of DSM may be bunk, and there's commonalities and different ways of describing. Psychiatry is one of the few fields where you just look at some random self-described symptoms and conclude different disease states with no biomarkers, that in fact they may be completely wrong. So that is a bigger category.
Absolutely.
Data categorization errors. And then the other maybe major category could be just, do we even have the data and how are we collecting it? So recently, for example, a whole bunch of Earth imaging satellites have gone up from planet, so you now can image the whole Earth every day. Massive new training sets for everything that just didn't exist 5 years ago. And the other one that I'm thinking about that's going to have a big effect economically is autonomous driving, where you, by definition, don't run robots in the real world before they've had some training. It's almost like a catch-22, and there's ways around that. But wow, wouldn't it be interesting if you could do massive training in a simulator, which they're doing, sort of the equivalent of Grand Theft Auto. So these cars are going to be great at plowing people down when the time comes, when the robot uprising comes. I say that jokingly, but the simulator training set, you have real people driving real cars. A real open question: does that help train your AI when you're observing, millions of miles and billions of miles of just human driving? And then in the early days, how do you incorporate the sketchy sort of edge cases where the autonomous vehicle does 99-point-something% of the driving right, and then you pop it back to a telematics operator for the occasional anomaly? Is that a good data set? Is that the right data set, or do you leave yourself open to very surprise events?
Okay, and I'm going to ask one more question, then I'm going to turn it over. Is that okay? Okay, yeah, great. So both of you talked about two pieces of this, which is the data as being something that I think you said, maybe only a few companies, right? Google has your data, right? They get it through all these apps, and maybe that's their competitive advantage, is they just have more data than everyone, sort of some data economies of scale, or I know Hal would disagree with that, but say economies of scope there. The other thing, though, and I think that if I look at Abe's presentation, right, you're just saying you've got better algorithms. Right, this data, by and large, that you're working with is publicly available, or with your partners. And I guess one question I'd ask is as I think about how AI is going to play out, should I think of companies succeeding because of their proprietary or advantaged access to the underlying data? Or is it going to be their ability for somehow something about how they develop algorithms themselves and maybe translate those algorithms into either decision-making or being able to drive that into decision-making and product development within the firm and in terms of outcomes. So where do you kind of come out on that?
I think I may very well be wrong on this, but my gut tells me that much of the algorithmic work is commoditized and open for now, at least I hope so. With notable exceptions in quantum machine learning, where the physical hardware of a Google quantum computing device or others could make a game-changing difference in a way that no classical computer could keep up with. So barring that major anomaly, which may surface any day now, much of the work is published, and so I think it really relates to business model and data in my gut. But I have this sinking feeling I'll be proven wrong on this. Yeah.
I agree. No, with the claim rather than with the that you'll be proven wrong. So,
30 seconds.
yeah. So when you were talking about data sets and domain expertise, right? Like in some sense, all of these are you have 100 data points and you have 1,000 parameters. You have polynomial which is 1,000 parameters, and so you have to put priors in. You have to have good data. Some of our data is public, and we see a lot of other people who don't do the same kind of cleaning we do, and I think that's measuring the wrong thing. That's measuring number of data points, but not bits of true information. But the other thing is, of course, every time one of these AI systems gets used, that's an opportunity to tune it. And so I think the way that you have better data and better algorithm choice, the hyperparameters that you were talking about, is to do more projects. So if only somebody had, an incredible number of projects, I think they're going to win.
Okay, well, we don't have that on, okay.
Actually got hurt, I guess.
Well, that seems self-serving.
Okay.
No, but it's true. I mean, like it's
No, there's reasons we're
orders of
doing it.
magnitude more experiments.